Hey, how's it going, everyone? Welcome on in. Happy Sunday. We're going to be continuing our ChatGPT and Rust. We're going to have a lot of fun getting I think we're going to do multi-headed attention today. That's pretty easy. That's an easy one. Hey, Ashish, good to see you. Hi, Steven. I'm with you. All right, bro, good to see you. Welcome on in. Happy Sunday. Let's build. Let's build together. I'm excited about this. This is really great. Let's get into it. Let's jump right into it. Why wait? Why wait? All right, so yesterday we added the norms. We should probably leverage these norms. Did we already do that? Do you guys remember? Let's see here. Where did we do that? We did the first norm. We didn't do the other norms. We also got to do the feed forward. All right. Oh, no, we did that other norm right there. So we get norm 2. We need to do norm 3 next. Okay. So this is where we left off yesterday. So we have to do norm 3, and I don't remember how to do that, but it is right here. All right. So we have to do something like this. How do we do that here? So attention is going to equal... What was out? All right, this is very important. Okay, attention is going to be out. And do we do another attention? Hey, top 1% engineer. Hey, good to see you, man. Hey, good to see you too. Happy Sunday. Welcome on in. We're going to be continuing our ChatGPT and Rust. So we are currently taking care of the norm layer, and then we're going to do a multi-headed attention, and then we'll figure out what to go from there. Oh, we got to do the feed forward part as well, which is just a MLP. It's not a big deal. All right, so, in fact, that's exactly where the feed forward is right here. That's why we need... All right, that explains the details. Okay, so that's why we didn't do norm 3 yet, because we didn't do the feed forward. So we should probably do something like that, right? A little bit of a feed forward there. So that means we need a linear, and we need a couple of layers and an activation. So let's start doing that. All right. So we need to deal with this here. I'll deal with that later. Okay. All right. Let's get our feed forward going, you guys. Where do we want to do that? That's got to be in the block, right? Because only the feed forward is only in the block. So that means that we're going to need to have some extra details here. Also, let's keep thinking. All right. So this will be the feed forward. So linear 1 will be an NN neural network linear layer. There we go. And then we're going to have a couple more. Right, so we'll do a 2 and a 3. There we go. And then we need an activation. We need to add an activation in. Okay. Hey, Snot, good to see you. Happy Sunday. Welcome on in. Good to have you here. All right. We need an activation, which I've not done in Rust before. So can we do a GELU? Is that something that we can do? Do you guys know? It's not found. Okay. Is it gonna be GELU? What about all caps? No. What about lowercase? Oh, wait. It's gotta be like this. How about that? Nope. Cannot find GELU in my art, so let's do this. We can figure that out. Google GELU NN TCH Rust. Let's see if we can find that. We got it. Do we got it? We got it. Activation, not burn. Not the burn library. We need this to be the TCH. It's got to be TCH, you guys. Okay, here we go. TCH GELU. I want the TCH GELU. Yes. Rust right here. Search GELU. Right there. Oh, wait, really? So it would just be .GELU then? So then we don't have to bother with it. We don't even have to create one. We just use it straight. Hey, Karthik. Yeah. Whoa, Karthik, how's it going? Good to see you. Welcome on in. Happy Sunday. Good to have you here. Karthik's here, you guys. That's crazy. Karthik, I see a lot of your comments. All right, so then we don't need an activation. All right, let me take care of these linear layers as well. So in our block transformer, we're going to return linear 1 as a linear here. We'll just do this. And what are the dimensions? I guess it's just going to be dims like this. And then we also need an output projection, but that's not here. We don't need to do that here. We need to do that on... Is it green? No. Is it green now? All right, now we're green. Okay. Oh, I love bacon, by the way, you guys. Oh, not the food. Bacon, not food. No. The thing that you see at the bottom of the screen here. This is bacon right here. How's it going there, SARS? Dual engine protocol. Greetings, Steven. Squirrel here. Oh, no way. You changed your name. My new channel for my work. Hey, that's great. Squirrel Sniper. Good to see you, Squirrel Sniper. Hey, Bonzupi, you're a vegan, Steven. What did you say? I know bacon. Bacon's at the bottom of the screen here. It's in yellow. It's the orange color. It's this right here. It's bacon. It's called bacon. It's just what the library is called. See who's back. Happy Sunday, man. Hey, how's it going there, Kunal? Hey, Kunal, good to see ya. I got your name that time, right? Only took a couple times. Hey, Steven, how's it going there, Shravan? Hey, Shravan, good to see you as well. Happy Sunday. Welcome on in. We're going to continue our ChatGPT and Rust, you guys. All right, so let me see here. Let me see. All right, so this gives us a feed forward. When we do our activation, we just do a .gelu, I believe. That's what. Yes, sir. All right, we did it. Kunal, you know my name now. I sure do. It only took a triple arrow, a non-coercive triple arrow exactly equals. That's what we had to do. Triple arrow. Okay. Triple equals for non-coercive. Okay, so I want to do my feed forward here. So I suppose what we could do is we could say, we could just make it like a little function for that if we wanted to make it really easy. Although, what's the point, right? What's the point? Just keep it all in the same forward. So we'll just say this is the feed forward. Yep, triple equals. Yes, sir. Strict check, we say. Yes, exactly. It checked data type also. Yes, it does. Triple equals. 1, 2, 3. Like that. Triple equals. Okay, so we'll do the feed forward. This is going to be out. Wait, hold on. Let out equals. And we're going to keep the attention. We have to keep the attention here, I think. Let me double check. Attention. This will be attention here, I think. No, yes, okay. Attention plus input. And then we got our attention here plus feed forward is what we're going to have to do. So we're going to have to do a whole bunch of outs. Self.linear1 and the attention. And then we're going to have to do this a few times here. Let's see. Is it good to learn Spring Boot and Java real-time projects? Real-time, yes. I don't know about the Spring Boot and Java part, though. It depends. Are you going to be using that in your career? Probably not. I don't know. I don't know many people. How's it going there, Park? Hey, Park. Park, good to see you. Welcome on in. Happy Sunday. The strongest coder of modern era. Hey, Darak. Darak, thank you so much. Good to have you here. Or is it Dora? Wait, Dora. Oh, I see. I see what your name is now. I see it. Good to see you, Dora. Welcome on in. Happy Sunday. Good to have you here, Dora. All right, what were we doing here? Okay, so we wanted to do a linear output. Is that going to work? It didn't like that. Why? Linear one isn't this? This is our block. So we have a linear here, and we identified. Oh, did we put it? Yes, this is here too. Okay, so we have a linear 1, 2, and 3. We should be able to deal with that. I think that should be something that we should be able to do, right? Self.linear1 field. Did I spell it wrong? Linear 1, linear. No, it's right there. I spelled it properly. Why does it say it's wrong? Rust has more use cases. Oh, wait. Hey, Karthik. Love it. The good old Karthik comments. Hey, Bonzupi, how's it going? Happy Sunday. What did Boots ever do to Dora? Oh, wait. Like, oh, right. Dora killed Boots, right? I know, right? Bonzupi, right? I was like worried about that. Hey, I was following over there. What's going on? Alt TV 00. Thank you for following. Appreciate it. Good to have you here. Happy Sunday. We're doing some the Rust, and we're going to be creating ChatGPT in Rust is what we're doing right now. Enjoy your Sunday, Kunal. Sounds good. You already did? Yep, we're going to join it. Let value equals valued. Oh, forward. Thank you. Thank you, Squirrel Sniper. I forgot. Forward. There we go. Forward with the R. There we go. Boom. Hey, Squirrel Sniper. Thank you so much. Can you become an excellent AI and machine learning engineer without learning full stack development? Yes, I think so. Yeah, I think so. Although you will have a problem though. Check this out. This is really important. And throughout my career, I've seen data scientists code. I've seen their code. And yeah, I know we have AI to write for us now. However, the code, this is the code they had, it did not look like production ready code. It looked like just a giant script of massive spread of waste. It was ridiculous. Sure, it might have been accurate. It might have worked fine in the notebook, but it didn't work for production. So you do need a little bit, a smidgen of some production grade coding, you guys. Hey, Sergio, good to see you. Welcome on in. Happy Sunday. Hey, Joshua Nutt. Joshua Nutt, good to see you as well. Happy Sunday. Let's see. And norm output. Norm output. Yes, norm output right here. That's the norm output. All right, then we have to do an activation. Dot gelu. Can we do that? Oh, it doesn't want that. Oh, it wants an argument. A string? Why does it want a string? Does it really want a string? What's for? Oh, gelu. Approximate and approximate? What is, how, what? Hey, Squirrel Sniper, do you know about this? Why would you need an approximate string? What is that? I've never seen that before. Well, I'm just gonna put something in. We're gonna find out. Let's try that. Let's see. Let's close this really quick because that is giving me the little icon there that's having issues scrolling. Okay. So I'm just gonna put some. I don't know what to put in here. Ha ha ha. All right, that works perfectly fine. I don't know why it wanted that. Let's see. Yeah, I'm a guy from the future. All right. Good. Yeah, you actually are from the future because you did already go through your day, and I'm just starting mine. Squirrel Sniper, right? What is that even supposed to be? I don't even know what it's supposed to be. Okay, so that'll be our first feed forward. We'll do a second one. I'll do la la la, and we'll do the third one. We do it without this gelu. Could we have to do like haha 2? So this will be 2, this will be 1. All right. I don't know why that's doing what it's doing, but it will. I would like to really know what this is about though. I would be very interested. Found out that the app development earn a lot, like cause people are very less. Wait, what, Kunal? What? I found out that app development earns a lot. Oh, yeah, a little bit, yeah. It earns pretty good. You can build some apps and you can release them. Okay, let's keep going, you guys. Let's keep going. So where are we at here? So I've got my feed forward, right? We succeeded on my feed forward here. And then we've got our output. Now we need to do our final norm output here. Let out equal self is norm 3. And then we're going to do out. Oh, wait. Do we need to store the original attention? Let's look back at our code. Let's look back at our code here. Okay. How do we want to do this? So we have attention. Wait, hold on. Wait, I did something. I need to undo that really quick. Where do we put it? Did we mess this up? Here, no, undo. Let's see here real quick. 1 second. Where do we put that? Where is that at? Oh. Ooh, oh, wait, okay, so that's not gonna work. Okay, here's what we're gonna do. We're going to go back to our original source code here. Greetings, brother. Hey, Code Mitsu, good to see you. Happy Sunday. Welcome on in. Good to have you here. Final out equals X. Feed forward out. X, so we need the input. Second residual skip connection, final out. So we're saying we need the input. Oh, wait, we got that right here, right? X, no. Oh wait, we did this part here. Where is that? For first norm, our first inputs. Yeah. So this is X. So we did that. X plus attention is what we did here. So are we doing this weird? This part worked fine for us though. Thank you. Happy Sunday. All right, Code Mitsu. Good to hear it. Oh, hey, food. Hey, food dude. From which crate gelu comes from? Is it torch? Yes. Yes, TCH. Thank you, food dude. App called Splitwise. I've not. Oh wait, I've heard about that. I've heard about Splitwise. Dinner and earn monthly. Yeah. Ooh, wow, that's a lot. That's a lot of money. Okay, here I'm gonna recopy and paste this really quick. That's what I'm gonna do, so that way I know what at least that looks like there. Hey, EdTech, good to see you. Happy Sunday. Good morning. Welcome on in. All right. Set, paste this. All right. So it's exactly the same. I didn't modify it. C /*. Okay. So I need to do, let me double check that I got these correct here. 1 second. So did we do our feed forward? No, our feed forward comes in at the end. So I need to do a norm 2, followed by our forward, and then followed by, so this is where I need to fix this right here. This part needs to be fixed. So I did the feed forward and we got our out. Oh, okay. So what I would like to do is say attention here, and then this is out like that. Okay. And then we do out because we already did the feed forward here. That right there. Okay. Out. Here we go. All right. We can fix that. We can fix it now. Wait. Ampersand. Oh, wait. This and dot forward. Perfect. Green. Hey, look at that right there. I don't know if that's good or not. We're going to find out, though. ARR is around 25 million. No way. That's a lot of money right there. Sheesh, just great revenue for an app. I know, right? That's a lot of money right there. Simplistic, satisfies hidden social demand. Very genius. Yeah, there you go. Code meets you. You got it right. That's exactly what the deal is. Okay, so we did our layer norms. We did our feed forward. Is this all look good now? Is this our complete block? So we've got our attention, key, query projections, our initial norm, query key value, attentions, feed forward with activations, and then final output projection, final norm output. Hey, how's it going there, SSH? Good to see ya. Happy Sunday. We're continuing on our ChatGPT in Rust, you guys. All right, I think that's everything I want. How's it going there, Yuval? Good to see ya. Hello. Welcome on in. Happy Sunday. Good to have you here. All right, you guys, where did we leave? So I think this is done. I think that's done right there. We succeeded. We just finished the MLP. Did I add that in here? Let's see. Where do we want to? In our main file here. All right. What's left to do? I'm going to say we did the block. Wait, we're not fully done with the blocks. We need to do multi-headed attention now. We need to do multi-headed attention. And before I do that, I need to pass data through the model to make sure that we're getting some good results. We got the Rust. Yeah, you got it. You got it, Sergio. Which Linux distro do you use the most? Me, myself. Well, probably, what is it? What do I use the most on Linux? Right now, of course, I'm using Darwin here, which is not a Linux distro. It's Mac, right? That's Mac. The distro I use the most, though, would probably be like Alpine or, right? Because in a Docker container, right? Docker container. Alpine, Debian. Those are the ones. Alpine and Debian. Between those guys. Alpine and Debian. Easy answer. So let's do our forward. Let's check to see what this runs here. Where is our code? All right. Oh, and see, running it, we gotta panic. We gotta unwrap. Approximate argument must be either none or 10H. Okay, so this must be on our GELU. Okay. So let's do this. Where is it? GELU. All right. So 10H maybe. Let's try that. See if that does the trick. And there we go. All right. I don't know why it wanted us to give a string value for that. Isn't that crazy? Kunal, you like Arch? Gotta get the Arch. Well, this mimics a skip connection. You've completely forgotten the original input tensor from the very top of the function. Did I? Oh, wait, Squirrel Sniper. Okay, let's double check. So we've got our input and our second input there, right? Are we putting that in the right spot? Should that go on norm 2 or norm 3? Scroll Sniper, just in case, because I've not completely forgotten it, right? So you get your first norm, right? Then you get your query key and value. Then you've got your attention with your input here, and input plus attention. And that creates another norm. And then you do a feed forward with the attention, and then you concatenate, or you add the attention here. Arc is, it's mine. It's mid, to be honest. Is it mid? All right, so it's oversold, right? It's oversold, maybe. Gotta love this quick fixes. Yeah, I gotta love them. Yep. What are you trying to do today? Amzad, we are going to continue building ChatGPT in Rust. It's going to take a couple of weeks. Don't worry, it'll take a couple of weeks. Which distro is stable for NVIDIA GPU? Debian, right? Debian, I think, is the most stable. Maybe CentOS, but probably Debian. I've only used Debian successfully with NVIDIA. Hey, man. Hey, Ruchi, good to see you. Happy Sunday. Welcome on in. Good to have you here. All right, let's see if that works. Still looking good. All right. Boom, right there. See, it looks good to me. Have you done the labels? We have not done any of the batching or feed forward yet, or the features. The good news is, though, we got our tokenizer, we've got the data, and we just need to create batches. And then we'll have our features and labels. We're good to go, we're good to go. All right, thank you for the hearts, you guys. Steven, you give me the best idea. Thank you, man. Hey, Ruchi, I'm happy to help. I don't know what I did. I have no idea what I did, but you're welcome. You're absolutely welcome. Okay. Let's see, NVIDIA distro, yeah. Are you on Linux? Hey, div, we are on, what do you call here? Uname, right? Type Uname, press enter, and it will give you your operating system. Currently it says Darwin. What does that mean? That means I'm running Mac OS. That's all that means. I'm running Mac. All right. Maybe we should delete the linear 3 and rewrite that specific section as a clean two-step projection. Just a thought, save lag. Oh. So you say delete linear 3. So we don't need linear 3, you're saying? Let me double check that. Delete linear 3 and rewrite that specific section as a clean two-step projection. Well, I mean, all right, well, let's write that, right? So you think just one activation? Like that? Okay. All right, Scroll Sniper. You asked for it, you shall receive. You got it. How's it going there, Rayan? Yep, Rust. You know it. We're doing Rust. Exactly. Dash A to get more information about the operating system. All right. I usually don't give that information away. Bonsupi. Since you asked, you guys, are you ready? All right. Here we go. It's a sneak peek. You only get that information once. Okay, it's gone. If you missed it, too bad. Let's see. Oh, approximate string JELU unsafe torch error. There goes your string. Oh, Foodude. String for JELU unsafe torch error. There goes your string. Well, I think. What if we put none? See if that works as well. Let's see. Where is that? Oops! I closed that. All right, no worries. Deactivate source, and then we say run. Okay. There is either one way or the other. It either wants tan-h or it wants none. What, can I put something else in there though? I'm just getting curious about that. What if I put an-h? Is that going to panic? Yeah, it does. Okay. So it wants tan-h. All right. Yeah, try that, please, Squirrel Sniper. All right, we did it. It looks good to me. We're going to keep it. Thank you, Squirrel Sniper. Thank you. You were talking about Debian or Darwin? Both. I was talking about both. I run Darwin. This is my computer right here. Darwin's my Mac. I will use Debian for NVIDIA. NVIDIA, great. It's perfect. Darwin works really well with NVIDIA. Arc also supports GNOME. Oh, it does, really? Okay. Good to know. Are you writing an LLM or training going to more interesting architecture? Yeah, we're messing around with the architecture. Yeah, we're creating our own. We're creating our very own happy architecture. And we're messing around with it. So yeah, this is our own from scratch. As you can see here, all of this code right here started from an empty file. It did. Completely empty. We did this. We started this a week ago or so. Thank you for the hearts, you guys. Okay, so where are we now? What do we need to do? Did we get this? Yeah, this part is gone. We don't need that anymore. So we are done here. We need to do this later. This is a to-do item. Let's see here, set, no paste. No paste, there we go. So we need to add the blocks. And then we'll deal with that later, though. We don't need to worry about it right now. Yeah, so this will be a vector of blocks, right? Looks good. You're more than welcome. Hey, Squirrel Sniper, yeah, thank you. Residual, oh wait, clean residual add using the original incoming input stream. Final out equals input plus feed forward 2. So I was wondering about that. All right, are you sure? Okay, so you want the original input. So you're saying original input plus feed forward 2. Let me think about that. Oh, so final out. Here. Let me think about that. So do we not need the third norm is what you're saying? No, we do need the third norm. Thank you for the hearts, you guys. Appreciate it. Good to have you here. Which MacBook you use? Because you mentioned about NVIDIA graphics. So like, for Debian, when I'm running on Debian, not Mac, I will use NVIDIA. I'm running on Mac right now, which is Darwin, and there's no NVIDIA. No NVIDIA on Mac. No NVIDIA. What tokenizer? Oh, what's a tokenizer? Here, I'll show you. Check this out. It's really cool. It's really neat. A tokenizer is like this. Here we go. Are you ready? All right, you guys, the chat was happy. The chat was asking about tokenizers. You see, there's a bunch of words here. The chat was happy. We got a bunch of words, right? 4 words. A tokenizer converts those into indexes. So 1 will equal the, 2 equals chat, 3 was 4 happy. That's what that is. That's a tokenizer. Done. Tokened. You tokenized it right there. Are you Sam Altman? Hey, how's it going there, Ronnie7? Go Edits. Good to have you here. Happy Sunday. You like Claude Architecture? Oh, the Claude architecture got leaked, really? Oh, Squirrel Sniper, thank you. Let me copy this. I'm gonna copy that real quick. Okay, let's get back to our code, you guys. Okay, so Squirrel Sniper says we gotta do this. Let's see here, struct, let fn. Here, I'm gonna keep these out here real quick. So this is Squirrel Sniper. At squirrel, wait, how do you say this? SQUIRREL sniper 138. Okay, so standard 2-layer feed forward structure. Gel U, ha ha ha. We have to say tan H here. And then feed 2. Linear 4. Did I get all that right? Oh wait, we're missing 2. We're missing 2 right there. Chaining 3 back-to-back layers just makes it harder for the gradients to flow backward through it. Oh, okay. So we're gonna delete linear 3. Here, there you go. Linear 3 gone. Linear 3 is gone. It's gone now. It's gone. Which newsletter you follow? Hacker News. I get a Hacker News newsletter that gives me all the top Hacker News events for the day. Jay, bro, I'm not able to open your Olama. Oh, wait, no way. Olama should work perfectly fine. Hey, how's it going there, Gabby? Hello. Welcome on in. Happy Sunday. Let's see here. Ooh. Perfect. Okay. JavaScript architecture get IG last month. They just recovered it somehow. Ooh. I don't know about that. I've not heard about that. How was your day, sir? The day is so far so good. It is 9 a.m. and we are currently building ChatGPT in Rust. RAG, can anyone explain? Oh, retrieval augmented generation. It's about search. It's what it is. It's search. All right, have you guys heard of RAG? It's that thing that people talk about on a regular basis. They say retrieval augmented generation. Really what it's about, it starts with search. So a Google search or a vector search, which is also what Google search is, and a keyword search. You want to create a really good search engine that is able to find snippets of text inside of your corpus, your documents, and then pull out specific snippets. It's going to take those specific snippets and then add them in as context to a large language model, and then it's going to paste your original query. So you type in a query, you're like, hey, what is the color of apples? And then it goes to your database, it searches for the color of apples, it does a vector search, it does keyword search, full text search, pulls back information, passes that to the large language model, and the large language model answers in natural language. That's what it is. Hey, Common, good to see you. Welcome on in. Happy Sunday. Good to have you here. Related to vector database, RAG, something like this. Yeah, so vectors is just one method of search. Vector DB is just one method of search. You also want to do full text search, FTS. You want to do keyword search and other varieties of searches, right? Not just vector. You want to pull that information back and then merge it. How to learn hacking, sir? Gabby. Well, start with using Metasploit. How about that? S-P-L-O-I-T. That might be a good starting point for you. A little bit of Metasploit there. It comes with some pretty interesting pen test tools. Pretty interesting pen test tools, you guys. All right. Where are we at? All right, let's keep going. So the one thing I didn't do that's different, so my feed forward is weird here. Linear attention out. So this is a feed forward. Then we do a final norm with our original attention. The only thing is, we need to review this. We say, review, do we want to do inputs plus out instead? That's for later. Oh, option 1, on layer stacking, uncommenting that vec transformer block is key. Yes, we will. Stacking layers sequentially. Yep, that's the plan. You got it, Squirrel Sniper. We're absolutely going to do that. In fact, should we do it now? Is it time? Should we do it now? Hey, Rad Kumar, good to see you. Welcome on and happy Sunday. Good to have you here. Why are you trying to make GPT in Rust? Because we want to learn it. We want to learn. We're exploring. We're engineers exploring technology. Make your own language for it? I don't know about that. Where to learn hacking, sir? You can learn about the tool. I would recommend. So like do a search for here. I'll show you. Watch this. Do this. Right. Google Metasploit. Sploit. Right. A little bit of Metasploit there. Then pen testing's test software. Get started. Here you go. Learn how to get hacking, right? There you go. It's just the beginning, though. It's just the beginning. It goes much deeper, but that is a good starting point. Right there. Okay. All right, where are we at? All right, so we want to do the blocks. Let's do the blocks, yeah? So we get an error because we're missing our blocks. So let's do a vector of blocks, yeah? All right, blocks. So we need to do a vector of blocks. I would like to do it inline. Or what we could do here is we could say, let blocks, which is a vec of transformer block, equals, is there a way to do this? There's got to be a way. Here, let me think. Here we go. 1 second. I'm going to pull up my notes here. All right. Okay. I would like to do a combinator is what I'd like to do. Is there a way I can do this? Can I do a combinator on... Here, let me copy and paste this real quick. Let's see here. Google this. Okay, let's go to AI mode really quick. All right, so I want to collect. I want to do a dot collect, one line, build a vector. Let's see if that works. Yeah. Oh, right there. Okay, a dot map. Oh, that's easy. Okay, we can do that. We don't need to see it anymore. We can do this ourselves. Thank you, Google. We just need a little push. A really quick, easy push right there. Love it. Hey. All right, so We do a range. So 0 dot dot, we'll say like 2. We'll do 2 blocks. Yeah, just 2 blocks. Dot map. And we will have the, we'll just say in, because we want the in. And then we need to transform a block. Do we want, when we do a new, yeah, it says block 1, perfect, okay. So we can do a format. So I'll do it like this, right here. I think, right? Can we do that? Is that something we can do? And then we'll go like this, just so we can read it a little bit easier. Although we don't need these right here. So we're just gonna do this and we say transformer block new. New. And then we'll say format exclamation point. And we'll say block, but we'll go block I. Or in, right? Block number. The block number right there. Then we need to pass in everything else that's the original stuff here. Here we go. Copy that. Okay. Paste. There we go. Okay. Close. Done. Easy. Is that it? Did we do it? Let's just push this all in one line because it's a little bit easier to see. All right. Okay. Looking good. Hey, Rocks Pub Nub. Yeah, you got it. Pub Nub. Yep. I mean, I'm wearing, you see right there. I don't know if you guys can see it very well. It's right there, you guys. All right. So with systems, no fragile tokenizers here. Yeah, the pre-byte level processing, bypassing old vocabulary, splits absolute immunity to typos and noise. Ooh, Squirrel Sniper, that sounds like a good tokenizer. How hard do you think it was to make ChatGPT from scratch? Quite challenging, because 1, we're doing it in Rust. 2, AI is very difficult. Combine the 2, exponential difficulty. I have some work. All right, sounds good, Rag. Good to see you. Kumar. All right. All right, artificial tokens. SS8138 deploys dynamic entropy patching to process raw data strings directly. Ooh, Squirrel Sniper. All right, that sounds pretty fancy. Sounds like you had a fancy one over there. All right, where is the thing that I wanted? Unclosed delimiter. Did I not do that properly? Oh, here we go. I need to put a comma. There we go. So I added the comma. And did I get that right? Let me see. Did I pull this in right? Becca blocks. Range. Map. Config. Dot collect. Forgot to do the dot collect. Collect. Ah. All right. A little bit closer. Unclosed delimiter. What do you mean unclosed? It seems perfectly fine to me. What do you mean unclosed? Here we go. Blocks is going to be blocks. BLOCKS. Okay. And then I have to change the VStore really quick. I'm going to call this mblocks. So that way it doesn't have the same VStore. Closing delimiter possibly meant for this. So where, oh, there we go. So that definitely needs there. What about everything else looks, so we did the norms. We don't need to worry about the norms. We've got our blocks here, so we don't need to worry about that. And then we added the layer norms. Okay. Rate my favorite software engineer, Stephen Blum, S tier. Kyle, good to see you. Happy Sunday. Welcome on in. Good to have you here. Do you know Cluely? I do not. I do not. What is Cluely? Programming different levels of mathematical variance. You're always good for that, Squirrel Sniper. Always good. The noise is the data. You want the noise. You want the noise. It's important. You want the noise. All right, where's my challenge? Unclosed delimiter, you're saying, huh? Unclosed delimiter? Wait, where's that? Did I really make it wrong? Let me check here. Yes, I did. Okay. Boom. Oh, I got, it's having trouble now. All right, so what do you want? Dropout argument never used. Yeah, I know. I'm fine with that part. Oh, let's see here. Okay. See if that's better. Yeah, there we go. Okay. Expected string, found string. Oh, all right, fine. Can I say dot to stir? Do we do that? Didn't like that. What about to string? Didn't like that either. How do we? Let's see here. There's a really quick, easy. How do we do this? And format. Oh, okay. All right, fine. Easy. Green. There we go. We got our green back, you guys. All right, let's rerun this. All right, looking good. So let me add our blocks back. All right, so we got our blocks now. Now we just need to loop through our blocks. And Squirrel Sniper, thank you very much. We will be doing our multi-stacked blocks. SF startup founded by Roy Lee. Oh, rocks, okay. What does Cluely do? What did they do? They raised mostly on their marketing. Oh, yeah, that's the way to do it. That is absolutely the way to do it. All right, so we'll do 2 blocks. We'll do 3. We'll do 3 blocks. Keeping a little bit better right there. Okay, so where's our next block at? So block forward. So what we could do is we need to iterate. We need to iterate through each of our blocks. And we'll do an out. So how do we want to do that? Let me think here for a second. Let's see here. Blocks. H equals. Okay, so here we go. Our attention, mute attention is going to be a tensor, right? So we need to define that as a tensor. So blah 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 is a tensor. Let's see. Attention. We need to do multiple. This isn't attention though. I'm just gonna call that out. There we go. Just keep things a little bit cleaner. Then positions forward. How do I want to do this? I suppose we could say positions, although we can't. It means technically positions. All right. For let's see. Block in and self dot blocks. Here we go. This is for you, Squirrel Sniper. We're gonna do multiple blocks now. I'm just gonna say mute out here. Then we want to grab our out equals out. And then this would be a block. Like that. I think that'll do it. I'm pretty sure. Do you think that'll work, you guys? Does that look good? And format. Oh, Foo Dude, yeah, thank you. I missed your message. We figured it out, though. We figured it out. Let's see. You don't use it, and you can get hired probably based on the fact that certain businesses, maybe not the FANG companies like Facebook, but you would make it use of it. Good to hear. Good to hear. Oh, Glib Globber. Hey, Glib Globber! You only want the signal, the true data, not the static. Oh yeah, the true data. Squirrel Sniper, I see what you mean there. Hey, Glib Globber, I like your name. Sort graph system was designed around the transformer architecture to have each activation function sampled on a high dimensionality mathematical graph manifold. Glib Globber, you're saying words. You're saying words. No, Steven Reed, SSH. I haven't learned to use AI till now. I'm currently learning C for embedded. Oh, nice, embedding, all right. And do I really have to get into AI? No, I mean, you don't have to. I don't enjoy using AI that much, and I'm currently enjoying learning without using AI. Yeah, okay. Well, that's right. Kyle's right. You don't need to use AI, and in fact, you probably don't want to if you really want to learn. If you're going to use AI, it's going to give you all the answers. And if you get all the answers, you won't know how to find the answers yourself in the future. It's a practice. It's a good practice. All right, here. Is it good? It compiled. Is it going to run? Hey, look at that. All right, did it actually go? Did we do it? We did our blocks, you guys. Look at that. Okay. Here, I'm going to put this over here so we see it a little bit better. All right, good. Look at that. All right, where all the pieces are falling into place. It's so easy. It gets easier and easier. Looks good, should run. Thank you, Squirrel Sniper. Yeah, looks good. Look at that, you guys. Oh, this is fantastic. Okay, that was for you, Squirrel Sniper. You said, hey, we should stack the blocks. There you go. They're stacked. They are stacked now. Okay. Where do we want to go next? What's our next thing that we want to do? Let me see here. So we did our blocks, we did our attention. We should do multi-headed attention, right? That's what we should do now. Right now it's doing single-headed attention, where it's attending to all the features in an entire cross-correlation coefficient matrix. We're going to want to upgrade that a little bit. We're going to upgrade it a bit. All right. Okay. So let me see here. I want... Where are we at? 1 second here. Okay. All right, looks good. Multi-headed attention, AI, keyword alert. Yep, there you go. You know what? We did the attention part. Now we got to do the multi-headed part, right? So we got to split some tokens up. We got to split some stuff up here. So where are we at here? Block. We need our block, and we're going to grab our attention, which is a separate function. Here we go. So we have to mess with this. This is where we have to currently do it. So to do, we did the layer norm. We did that. I'm going to put a little green check mark there because we deserve it. We did that. We did it. 4 linear layers. Wait. Oh, yes. Yeah. Hidden states. Query key and value space. All right, we got those. And 1 to project the concatenated head outputs back to the final dimension size. Got it. Okay, so we need to get one more linear layer. Good to know. All right, so let me look around here. I like what you said there. That makes a lot of sense. Let me see here. Grab here. Okay. All right. So we need to change how we're doing some things here, right? We have to change our, we have to change the view of the query key and value, which, as we all know, are the same input data. It's the same input data. And then we need to split them up by adding a 4th dimension, right? So here, this is actually pretty short. So this is going to be I'm just going to call this multi-head equals, and it's going to be based on this. So we got our batch. So it's going to need to be a batch. And the sequence. Got to keep that. And then here's where we split. So we need to split the tail end into difference based on the number of heads and the current dimensionality, right? The dims, the features, really. So the F. So this is the dimensions here. This is the F. So basically, we need to say 1 comma F for the exact same thing as before. This is what we had before. It's gonna get it ready for the heads. Then we need to do some division here. Don't rush into the multi without the other layer. Oh yeah, we're gonna need the output projection, yeah, down here, right? To do output projection, restore concat heads, right? That's what we have to do. That's what we got to do right there. That's the thing right there that we got to do. Restore, store. We have to do this. So that is something we definitely got to do. Let's see here. We need to do our. Let's see, what is this? 1 second here. Okay. Where's our inputs at? So these are our inputs, and I've separated those out as separate query key and value tensors. They really only need to be one tensor. It only needs really to be one. So let me see how I'm doing that really quick. Query key and value. Oh, projection. Oh, because I'm not concatenating my projections. Okay. Oh wait, hold on a second. Wait. Okay, hold on. Hold the phone. Wait a moment. I believe this is where I need to change the shape. So I've got my query. Let's see. Let me think about this really quick. View and then transpose is what I have to do here. All right, let's think through this, you guys. Glibglobber, what are you saying over there? I meant instead of using the 2D activation function, you have a much higher dimensional, which you can sample your 2D activation function from, so you can train in which activation function you use where. Glibglobber, did you say something before that? Have you looked into using any sort of graph system? Oh, no, I haven't. When designing around transformer architecture, I was going to have each activation function sampled from a high dimensional mathematical graph. Okay, yeah, I haven't tried that before. I don't think I've tried it. Let's see. Currently working on book on how to make Android using AI. Ooh, that sounds like a good adventure. Hey Mario Srini, good to see you. Happy Sunday. Welcome on in. Good to have you here. All right, so we're gonna have our work cut out for us here because we've got our projections. Do we project first, right? We project first, and then we change the shape. I think. Right? Yeah, I think we project first, which we did. So here's our projections, and then we change the shape. So we do our shape change here, and then we proceed onward. Okay. So let's change. Let query equals. We have to do some variable shadowing here. Query query dot view multi-head transpose 1,2. We do the same for our key and our value. Key. There we go. Okay. And then I need to do the other way, the invert it for the matrix multiplication, I think. And then we already have our scaling, so we're good. All right. I don't know if that'll work. I assume it might. Oh wait, it won't because we did not have our output projection. So this is where we're gonna have a problem, right here. Hey, Quantified Quantum, good to see you. Welcome on in. Happy Sunday. Hey, Maverick, thank you for saying hi. Welcome on in. Good to see you as well. Wow, you're so intelligent. Thank you. Thank you. We're just working our way through it. We're making it run. Oh, hey, Kyle, you've got the burn library there. Ooh, I just saw your link there. I saw your link. Danger zone. You linked a crate to the burn neural network. Yeah. So we were doing burn. And then we dropped it because it was ridiculous. Here's the deal. Check this out. When you're building a library for other software engineers, you want to make sure that you're going to make their lives really good. You want to give them a good user experience because you're building a library for end users. You don't want to have forced exposure to internals of the framework itself. Burn library completely misses the mark on that. It exposes all the abstractions that are supposed to be hidden away inside the library itself. And it forces the user to write boilerplate upon boilerplate upon boilerplate. You don't want to do that. You did it wrong, Burn. Sorry, I didn't want to do it. Oh, my mad, got it? Hey, it's all good. You know what? What library does a really good job is the Torch library. libtorch, the C++ libtorch library. There you go. That's the answer. That's what you want to do. They did it right. And thank you to Neva for pointing that out to us. Okay, so I need our output projection here. Let me see here. I need to define another linear layer. This is going to be our ATTN projection, linear layer, colon value, so ATTN. How about we say attention? There we go. We'll use the whole attention. Attention. There we go. And then we have to define the attention up here as well. in the query key value up here. There we go. Linear output. It built? How is that possible? What? Are you kidding me? Change let query equals, oh, scroll sniper. Okay. I will see what you say in a second. All right. All right, so we're doing it. I know I wrote this weird. I put the attention in its own function because we're doing our projections first and then we do the attention. So I think it's actually fine. I did this more based on the mathematical approach, right? From the algorithm, right? So I think we're doing this in a way that's separate, right? So we're doing the projections in the attention, the scaled dot product here. So from the attention all you need paper, we're doing this properly. We're doing it proper. Okay. And then we changed, everything looks good there. Now we just have to get our projection. And we need to convert it. This is the part that I don't know about, and I'm gonna need help on. I do not know about this part. I mean, I know of it. So here, let's go back to our help here. Where is it at? Where is it? Here, right here. Okay. So we need to do this part. Right here. We need to reshape it. We need to transpose back and then reshape it again. With another projection. I guess? Okay. So let out equals let's see here. We have to do something like this. Let's see, self dot attention projection and out dot forward dot transpose 1,2 dot reshape batch sequence features like that. Okay. Return out. Okay, did we do it? Moment of truth. We're gonna find out as soon as I press enter on the keyboard. Did we do it properly? I don't know. No. Oh no, we didn't do it. Okay, so we got a problem. Unexpected argument. Wait, why? Oh, dot reshape isn't a real function? Do we know? Can we say view? No, we can't because we transposed it. If you do transposition, changing the view, no, you can't do it. Doesn't work. Okay. Reshape is imaginary. It doesn't exist. It's not a thing. It's not. Okay, here we go. All right. Let's align this so it's nice and easy and pretty. Okay. Did we call it sequence? We did. Yeah, it's called sequence right here. Sequence and features. This should work. The only problem is reshape doesn't seem to be a thing that it wants, that it likes. Unexpected argument 3 of I64. Unexpected. So what is it looking for? What does it want? Nah. Oh, right. Okay. So it wants a tuple. Unsatisfied trait bound. Does it want an address of a tuple? No. Address of a vector. Really? Is that it? Is that what it wanted? Do I have reshape anywhere else? How about view? Do I have view anywhere else? Where's my view? View. All right. So, okay. All right. Reshape. Is this correct? It says it works. All right. Let's see if it runs. All right. We got a problem. All right. No, I knew. I was like, that didn't make any sense. All right, Mat 1 and Mat 2. Does it say where? What line? Error. Mat 1 and Mat 2 shapes cannot be multiplied. Obviously, those shapes are not they are not commutative. They do not work. We have to make an AI which can listen to multiple voices at the same time and respond correctly. Maybe it requires a new kind of background function and logic. Ooh, yes, you can build that. You can build it. Yeah. So if you have, are you saying, J-Bro, are you saying having two people talk at the same time? Right? Hello, blah, blah, blah. But then someone's responding, I'm doing perfectly fine, thank you. Hello, well, that's great to hear. Do you say they're talking at the same time, and so you're hearing a mangled of voices? Oh, view multi-head transpose. All right, Squirrel Sniper, let's try it. Let's try it out. Query.view. So query equals query. Wait. Oh, wait. Hold on. View multi-headed transpose. Did I already have that? Yeah. We got that right there. Yep, Squirrel Sniper, we got it. The matrix multiplication requires head dimensions to be at index 1. Batch heads sequence dims head dims. Oh, did I do it in the wrong order? Got it. Okay. So 1S. Like that. All right, let's see if that made it better. Did it do anything different? Did we do different? Oh, we got closer. Hey, we got closer. Look at that. Expected size for the first dimension in batch 2 tensor. Well, did we though? Is that really what we want to do? We might be doing this differently. Yes, exactly 2 or 3 or 10. Let's see, J-Bro. Oh, ooh, that would be a lot of people talking, right? That would be a lot of people talking. There's a way to format screenplays so that the format already exists with multiple voices at the same time. It's a thing. It is a thing. Already, we've got an idea. So we can start using that concept. I like it. Good idea. Okay. So let's keep going. Where are we at here? Expected. So this is the most difficult part of the full GPT, in my opinion, is getting the multi-headed attention working. How's it going there, Manic? Good to see you, bro. What's your final goal? We are going to be building a ChatGPT using Rust and TorchLib, which is the most prevalent library in AI today. It comes from Meta, right? Facebook. They wrote libtorch, and it's a C++ library, and we're using Rust. We're using it in Rust right now. So we are going to, if you use view multi-head, the tensor dimension becomes batch sequence heads dims. Okay. Hey, from San Francisco. Hey, all right. Hey, Mr. Jackson, thank you for the 10. Appreciate the gold coin. Thank you. Salute. Thank you so much. I appreciate it. My gratitudes to you. That's very nice. I hope you did it. We were successful before. We're going to be successful again. It's perseverance. It just takes perseverance. So as you can see here, we've got a nice, giant, enormous error on the screen. And we have to figure out how to deal with it. Right, you guys? We have to figure out how to deal with this. This is scary. It's a giant, scary C++ stack trace. If you're not a programmer, I'm sure your streams are really hard to understand anything. A little bit. Reshape, transpose, queried, batch heads, sequence length, head dimensions. Here, I'm going to copy and paste that, Squirrel Sniper. Run matrix multiplication against the transpose key. Output, yep, -2, -1. All right, so we've got that part. We got that part. Where is the thing that we want? Are you sure? Are you sure this is what we want here? I think I want I'm pretty sure I want it the other way around. Although it doesn't matter really. I suppose it doesn't. It's going to be the same thing either way. It really doesn't matter, I assume. It needs to be. All right, so this is the number of heads. Let's see here. Head dimensions. So head dimensions and number of heads. So currently we have one head, right? Let me see if I have this. Heads. Here we go. Okay. So this is heads. Let's go ahead and give it like 4. We'll do 4 heads, right? So self.heads. Let's see here. Self.heads. Are we using this anywhere? Heads. Square root. Yes. Okay. We'll leave it there. Yeah. Okay. All right. Heads. Attention. Here we go. All right. So this will be self.heads. Self.heads. Which may or may not work. I think we might have to say as I64. And then we need let head dim do yes, head dimensions is going to be features divided by self.heads. Okay. So I need this, and then I need to match features to be head dims, like that. All right. Head dims expected. I64 found tensor. Oh, right. Okay. How do we do this? Let's see. As I64. Can we do that? Expression can only be used to convert between primitive types. How do we convert a tensor to? How do we convert a tensor? Do we do from? How do we do this? Google TCH tensor convert to I64 scalar. Do you guys know? See, int value. Okay, is this it right here? So is there a better way to do it? That's weird. That's a weird way to do it. Are you sure? Is there other option? Is there more options? Okay, Mr. Jackson. Hey, Mr. Jackson, good to see you. What program do I need to download on my computer to actually do this? You're gonna need Rust. So you say Rust install, then you copy and paste the install command. And then you also need libtorch, and I installed it through pip. So I did a pip install torch and torch vision. That's gonna give me libtorch. Then you have to create a virtual environment and route to the libtorch Python directory, which includes the C++ heads. And then you can pass that as environmental variables. So that way, when you're running your application, it'll do the trick. It'll do the trick, you guys. This is turbofish. I don't want to do turbofish. Try from works well for 1D and for float vectors. All right, let's try this. I want this. I like this one. It's a little cleaner. It's a little more straightforward. There's a duck. Too kind. Oh, I'll be even better. Here we go. Too kind. That's what I want. I like this idea right here. There we go. There. Right there. I like it. How about this? Let heads equals heads. Here we go. Number of heads. Though. Yeah, actually, that's probably fine. Head dimensions. Yes. Okay. This will be heads. Here we go. Head dimensions. Okay. Expected I64. Is this not? Oh, wait, that's not I guess that's still a tensor, isn't it? All right. Yep. Thank you, Kyle. Appreciate it. What are your thoughts on Zig Clinker plays? Good question. I like Zig. I think Zig's fine. I have not programmed much in Zig. I do like how it's got a very specific output to binary, right? You're going to create your build. So it's in the realm of Go. I do not know much more about it. I would say it's something that I should explore. What we're going to do on this channel after we finish building Attention's All You Need in Rust, which is, the most challenging thing, we will go to Haskell and Zig. Those will be things. Before that, though, there was a very, very specific ask that we get to on our Discord. There's an ideas channel here. And on the ideas channel, there was a request to do RAG. They wanted us to, and they want to build RAG. And so we're going to build it, and I'd love to do TurboVec plus Gemma embedding, and with sort of, we could do Fast API, or we could do Axum. And most people wanted Axum, so that's going to be the next thing that we do. Oh, nice. Haskell would be a huge change. I know, right? Clinker plays. I'm looking forward to it. I think it's going to be a lot of fun. We're going to do Haskell, you guys. We got so much time on this channel. We're going to do so many fun things. Right now, we're focusing on AI and Rust. Then we will go to Haskell, and then we'll go to RAG, and we'll go to so many fun things. We'll do some game dev. We'll do more AI. We're not done yet. We got so many things to do. Always call this in the first source tensor, your float type. Let's see. Inval. Okay. Works well. All right. So I'm going to try this one instead. All right. Here we go. Let's try this. This is going to be our heads. Here we go. Let that out there. And tensor. Looks good. Paste. Boom. Save. No implementation for i64. Oh, it's a result. Fine. Okay. There we go. All right. Not my favorite approach, but you know what? It does the trick. Release the AI, J bro. It's coming. Don't worry. We got to train it first. We even got to finish writing the most challenging part of this. Hey, Erdem. Hi. Good to see you. Happy Sunday. Welcome on in. Good to have you here. All right, you guys. Let's see. We've got plenty of time left here. Okay. When are we going to do some data structures and algorithms? Well, let's put that in our ideas. Yeah, let's do that. I like we can make a B tree, right? We could do a hash map. We could do a linked list. Yeah, DS data structures algorithms. All right, we could do Rust. We could do Python. Other. All right, build DSAs. Post. You asked it. There it is. We did it right there. Let me type there. B-U-I-L-D. There we go. Proper spelling. Steven, maybe we can do something special to implement continuous state space modeling or quantum-inspired qubits via complex value tensor manifolds. I would like to do some more quantum. I've done this before, you guys. I think that would be a lot of fun. Can you read my past comment? Erdem, what'd you say? Erdem, you said hi. Cardinal Erdem, you said hello. That's it. That's all it said. I don't see anything else. There's nothing else. You have something special for you then, squirrel? All right. Sounds good to me. Okay, so is this... So we're still at a broken spot here. 1 second. We should still... Yeah, should still fail. The output tensor is size of 5, match tensor. See, this is weird. This is getting weird now. I don't think this is correct. I think I need to change this back. Where is this at here? I need to switch this and this. Let's try this again. All right, so I need to have a 2D matrix there. All right, 20 by 5 and 10, 20, 120, 120. Okay. So, let me think about that. Because otherwise we'd have low rank matrices, and we don't want low rank matrices. We need to see where this is occurring. So let me see if I can just simply return. Here, let's do return query. Let's try this again. All right, good. Let's try this. Try this again. Here we go. All right, here's the error. All right, size of tensor 128 must match the size of tensor B32. See here, okay. Am I doing this correctly? All right. Would you suggest building a database out of Rust to showcase your skills? Ooh, yeah, I think that would be a good one. Yeah, that would. That would be really good. You actually wrote it. The top of the message, maybe. It's been a while. Let me check. Here. It says, the only thing that you said today. All right. Here we go. The only thing that you said today. Here we go. Zoom in on a bit. It says, today you said, hi, can you read my past comment? I wrote actually on the top of the message, maybe. That's it. Just 3. Only 3 show. If your message isn't showing, that means it got moderated by Google. Google was like, it didn't want to show it. They didn't want to show it. All right, so let's see here. This is, oh, interesting. Let's see here real quick. Okay. All right. Let's see if we can return All right, where's our attention at? Where are we calling attention? Right here. Okay. Return attention. All right, let's do this. All right, so it happens even before I return the attention. All right. I32 equals 4. Wait, what? Posted the full script for the multi-head in your community page. Oh, really? Oh, wait, on YouTube. Okay. Let's take a look here. Okay, let's keep going, you guys. Let's keep going. We're almost there. Community, where are we at here? Courses, posts. Okay. Wait, how do we get there? Community. There we go. I don't see it. It's not showing up. Did you put it on Discord maybe? No. Maybe link share? No. Where'd you put it, Squirrel Sniper? How's it going there, Nitish? Good to see you. Hi. Welcome on in. Happy Sunday. Good to have you here. Fully connected networks yesterday, and what do you recommend me to implement today? Do a CNN. I think that's a good one. A CNN. Yeah. A convolutional neural network. I think it's a good one. Same as last. It's probably not in memes. LinkedIn, general. So it's not on Discord? Squirrel Sniper, not on Discord? Also, I don't see it on YouTube. I don't see it. I don't see it. It's in the places. YouTube? Okay. It must have got moderated because I don't see it. If you put it in a comment. Oh, how you put the caption doing live. Oh, like this. Yeah, right here. You know what? That is my code that I wrote many years ago. Where is it at here? Let me throw it over here. Yeah. This is called subtitles for your YouTube and Twitch. I wrote this 8 years ago. 8 years ago. 8 years ago. Right there. This is software that's available free forever. It'll work for you right now. All you do is follow the install instructions for your OBS and you're good to go. You're good to go. Hey, how's it going there, Sanvi? Siab, thank you so much for subscribing. Appreciate it. You joined the right channel for software engineering. We're building ourselves a ChatGPT today in Rust. That's what we're doing right now. Let me make it SS. Okay, Squirrel Sniper, sounds good. All right. I'm almost good here. So let me think about this real quick. All right, so I've got number of heads, head dimensions. Oh, here. Okay, 1 second. This might do right here. Tension. Yep. Okay, right here. Looks good. Okay, I need to flip this, right? Do I want it to be number of heads and then head dimensions? So this is the number of heads and the head dimensions. Okay. So this is already good. This would be wrong if I did it like this. It'd be weird. All right. That is going to be weird. What's the shape it says? Yeah, it's a weird shape. Okay. Undo that. Here, what we should do is, I've got an idea. Let me make it easier. Let me make it easier really quick. Okay. Let me go like this. 1 and wait, let me undo that real quick. Let's redefine this as 1 and the number of dimensions is going to be F. Okay. Oh! No, I did that here. Okay. Head dimensions, heads. Number of heads, dimensions. Okay. Let's try that real quick. All right, what do we got here? 5 and 128. Where is it doing that at? Let me see here. Let's just do return query. Okay, good. It likes that. So what we're going to do is we're going to say query.print. So we see what that looks like. And then we need to turn off other prints here because I'm printing out too much stuff. main. Let's see, where's our main at? Print. Let's not print that for now, okay. All right, see what we got. And no, what? Whoa, hold on the phone, hold the phone. Where is it printing? No, I like that. Oh, it's doing this. No. I want this. I want the shape. I want the size. Print LN exclamation point. Question mark. There we go. There we go. See if that works. There we go. Okay. Yes. Excellent, excellent. 3 blocks. We got 3 blocks. Nice. Okay. Are there good free APIs to make your own LLM? Yeah. There are. You just install it. It's software. It's free software. It's free real estate. You absolutely can. Absolutely. Yes, you can, Sahan. Yep. Free SD. Well, free libraries, really. Yep. You sure can. We're doing ourselves. We're writing it ourselves right here. Okay, and I want to print the multi-head as well. Let's do multi-head like that. See, print this out here. Yep. Okay. 15128. Right. So it's batch sequence features. Let me also see what this looks like when I do this multi-head in this style. Here we go. Okay. Yeah, that looks good. That's correct. That is the correct output. Yes. Okay. So thank you for the hearts, you guys. Appreciate it. Let factor U32 size. Let target equals 128. Target, the output. Yeah, the output. Yep. That's it. I see what you're doing there, Kyle. We're getting close. We're getting closer. Okay. A little bit of debugging here, you guys. Easy, easy. I want to... Let's see here. All right. So we're changing the view, and then we're transposing. So I would like to see what this looks like. The split query. So let's grab this and type in the split query. And we can just say print. Make it really easy. All right, that's a split query. Oh, wait. No, we want the size. We want the size. I don't want the actual output, because that would be annoying. This is the split query. Here we go. Split query. Let's get the next song going, you guys. All right. Thank you so much for hanging out with me today. We're going to get our music going here a little bit more. 1 second. Let's go back to the beginning. And next song. Okay. All right. 1 second. Okay. What are the advantages of building GPT in Rust? The advantages are mostly learning the algorithm a little bit better, because you wrote it once by scratch. I wrote it once by scratch myself, and then I wrote it a second time in Python using PyTorch, and then we're writing it a third time in Rust. The advantages from actually having it in Rust is now you're going to be able to build a binary that's going to run a lot faster, right? So Rust is going to be maybe so much faster than Python, like a lot faster. Now, not a little bit, a lot faster. And we are going to see what this looks like really quick. Okay. What does that look like? Yeah, see, this looks correct. So 3, right? That's the correct shape. It's a split query. Now that we've changed and transposed it. See, now this is odd. This looks weird. Right? It feels weird to me. Right? Because it goes... Like, I would want to keep it like here. I don't know why we have to... Maybe we don't transpose it, maybe? I don't know. Here. try that. What does that look like? Split query 154. What was it before? It was 145. Okay. So it's changing these two segments here. All right. Well. Okay. We will figure this out, you guys. We will figure it out. Where do we do this? Let me see here really quick. I need to figure this out here. So here's our final output shape. When will we compile this or complete this? I want to go to bed. Oh, hey, it's gonna be a couple weeks. Don't worry, we're gonna do it in a couple weeks. It won't finish today. We're not finishing today. We have about maybe 30 more minutes. We'll be streaming for 30 more minutes, and then we will figure out where we left off. And then on Monday, tomorrow, we will continue from there. We are getting really close, though. We're getting very close. The multi-headed attention always gives me a struggle because it's a lot of changing. It's a lot of stuff that we're changing around. And this makes it a somewhat challenge. So we want to... So we've got our projections. We already threw our projections in. We're changing the view to batch, sequence, and then features. Then to multi-heads and, hand optimized assembly, organized processor instructions. Is this Rust pure? It is nearly Rust pure. 7 Allah. 7 Allah is nearly Rust pure. So all the code that I'm writing is Rust. It's all in Rust. The library we're using is TCH. I wrote my own tokenizer, and we're using the TCH library, which is going to be able to put our workload onto the GPU for faster performance, right? So I'm using TCH for that. All right. This looks correct. So our view. What happens if we don't... Wait. So if we do the transposition... All right. So that's a split query. All right. I would very, very much like it if... Maybe if we go back to what it was before... And then we reconfigure this again. Now, this might be a problem. All right, so what we need to do is figure out what our output is. I've got an idea. Okay. So let's go back. Let's get rid of these things. All right. Okay. So we've got our heads, our number of heads, head dimensions, the split looks good. Reshape transpose. This part works here. Oh, the only problem... Okay, so... Okay, that's right. Our problem is here. What would be the name of this model? GPT, Generative Pre-trained Transformer. That's what, right? That's what it is, a GPT. We can name it whatever we want, though. You guys want to name it something different? Mohammed, what should we call it? Let me see here. Okay. I want to rerun this and figure out where it's failing again. 20 by 5. Why does it say 20 by 5? And 128. Oh, no. Yeah, maybe. Let me think about that. So is this where the problem is, right here? So let's do return value. See if that's where the problem is at. No. I need to just get the output directly. Given normalized shape, expected input shape 128 by got. Yeah, okay, all right. That's good. Let's see. Where is our forward at? Where's our forward? Right here, attention. Okay. So we're just gonna return attention. And this is a block. Okay. See, transformer, forward. Okay. Let's just do one forward here. Turn out. Do that really quick. So this should not fail. All right, so that doesn't fail. Good. Then I want to do one block. So let's do, can we get a slice of this? So let's say self.blocks 0.forward out. Let's try that. Okay. All right. So far, so good. Okay. Attention. How many VRAM you used? This is going to be very small. It's only like a few gigabytes. It doesn't need to be very big. Not very big at all. This is all rocket science to me. Hey, show, good to see you. Welcome on in. Happy Sunday. Yeah, we're building GPT in Rust right now. So we are at a part of difficulty where we need to create our multi-headed attention and split our QKV into heads, which we've done. We did that. So now I'm going to check to see if I can get my out here. All right, success or no success? All right, that succeeds. So our one pass works. Do attention. Here we go. One pass, okay. 128. That looks correct to me. That looks correct. Although it seems weird that it's there. Where's our shape? Oh. So where are we at here? Shape of query. Yeah, shape of query. I would like to do shape of output. Here we go. All right. Where's our attention? Here we go. I'd like to say attn.print. No, I want to do the size. Where's that at here real quick? Let me jump back. I want this. The attention size. See what that looks like. Okay. All right. 14532. That looks good to me. Right? And then our output should be back to 15128. So this is out. 15128. All right. So here's our problem. Okay. So it's on this final output here. Here we go. This is where the problem is. So we can't just throw the projection on the output here. So this is why. So this is the attention. Okay. We're getting close, you guys. We're getting real close. Hey, how's it going there, Bob Paul? Welcome on in. Good to see you. Happy Sunday. Are you willing to train this model? Yes, we will be training it. We will. As soon as we get the opportunity. Right now, we're in a bug. We have to get our matrices the right shape for the multi-headed attention. We had it working. It was working perfectly fine with one head. Now we turned it into 4 heads, which is where we take the features of the model per token and we split them. And then we self-attend on those features directly. Thanks for the hearts, you guys. Appreciate it. Hey, Quick Fix. Good to see you. I'm building a DIY CAPTCHA program. Quick Fix. Are you? Wait. Hold on a second. Quick Fix. All right. A local daily DIY CAPTCHA program. Open source, simple. All right. So, Quick Fix, you were already here. I didn't mean to re-welcome you. Sorry. No rockets involved, I'm afraid. I know, right? Technically, rockets have thrusters, which apply force to a vector. Yeah, Bob Paul. Yeah, you're talking about physics. Physics and AI are different. They're different things. They use the same terminology, though, which is really frustrating sometimes, I think. Happy Sunday. Thank you so much. Sylvan. Hey, Sylvan. Thank you again. Yep, Sylvankini. Wait, Sylvakani. I always have to figure out how to say your name there. Just making a joke, Bob. Paul. Oh, well, you know what? Good job. You did it. You did it. It worked. Congratulations, Quick Fix. Good job. You did it. That's great to hear. You got it to work. All right. So this part's broken. So we had to fix this. This is the part that's broken. Right here. We have to figure out how to deal with this. Perfectly said my name. Oh, all right. Silva Connie. All right. Let's see here. So where are we? This is the part that I need to fix, and I do not know exactly how I want to do that. There's maybe something else we have to do. All right, there's something else that we have to do here. So do we have to transpose first? So we've got our, are we doing this right? Maybe we're not doing this right. So let's change this up. All right, so we did this part here. This is the attention. We take our attention and multiply it by the value. So it's a matmul for the value. This needs to be transposed. Like that. And then we apply the view. Contiguous. Us. Right? Contiguous. Then we do our view. Or reshape, basically, right? Okay. Our dot view. And we do this view here. Okay. And then we don't have to do this part. We just do a projection at that point. This makes sense. You guys, I understand it now. I get it now. I figured out where the problem was. I'm taking the projection, which is expecting a 128 by 128, I believe, right? Let's figure that real quick. 128 by 128. Is it a... Yep, 128 by 128 right there. And I'm trying to apply it in a way that it doesn't want to do it. So this is where our problem was. Right here. Output. And then we just do self-projection forward attention. Like that. I think that's it. I think that's it right there. Let's get rid of this. All right. We're going to return. Let's make sure our attention is correctly shaped before we do it. Let's see if we did it, you guys. We might have done it. The trait shape is not implemented. Let's see. The trait shape. So it doesn't like that right there, is what you're saying. Let's try this. Wait 1 second. Oh, right. No, that's fine. Okay. Expected end tensor found tensor. This is the same kind of tensor that we always do. It's always the same. Perfectly set. All right. So, bro, how many programming languages you good at? We're pretty good at several programming languages. Thank you for asking. Thank you, Sylvan Connie. Good to have you here as well. I got to practice your name is what I got to do. I got to practice your name. All right, bro. JavaScript, TypeScript, Python, C, C++, Java, Ruby, I guess PHP, or a little bit of Erlang, smidgen of Haskell, but not enough Haskell, Golang, Rust, like we're doing right now. That's a pretty good start right there. Oh, C#. We got C#. I like C#. C# great. Perl. I can't forget Perl. That's my origins. That's where I come from, Perl. Maybe the head is pointing towards the value, which is also pointing towards another pointer of the head. So the head is influencing another head. I don't know, just an idea. Hey, Bob Paul, thank you for you're helping out right now. You're helping out. Steven is messy of coding. Oh, hey, Peter Parkour. Peter Parker, good to see ya. Welcome on in. Happy Sunday. Yep, we're gonna make it work. We're making it work, you guys. How's it going there? Nilish Palmer, thank you. Welcome on in. Good to see you as well. Happy Sunday. Thanks for saying hi. All right, so let me go here. Let's just return out. There we go. Is that an error? Why do you not want this here? Okay. Make sure that still runs. Whoa, hold on. Here we go. Okay. Success. All right. So now we need to figure this out here. Where do we want to do this? We do our projection at the very end. Return out. And then I want this projection done here. But before I do that, I'd like to make this work. But that has a problem. Do we want to do... How about this? Reshape. Alright. Alright. No errors. No errors. Good. Okay. Let's now see if we can return attention. Looks good. Okay. So far, so good. Now, I'd love to see this. See what that looks like. That's the right shape. There we go. Hey, now we can do our forward and return our out. I'm pretty sure that's going to do the trick right there. Oh wait, didn't work. No, come on. Expected tensor. Okay, right. I was like, no, I'm pretty sure we did it right. Hey, there we go. That's what we needed right there. All right, I think we did it. Okay, now we can push it through a few more blocks, you guys. Just a few more blocks. Here we go. All right. Let me see here. Let's pull that up there. Can you see that? Can you see the flickering? I don't know if you can see the flickering. Redless Saber. Good to see you. Welcome on in. Thank you for the party poppers. My light is going weird here. Let me go over there. How about that? Okay. Oh, no. All right. How about that? You better now? It's Code Forces. Hey, Jay, good to see ya. All right, you guys, look, we did it. Okay, we're in a really good spot right now. Now that we did our multi-headed attention, right? Did I get everything in the right spot? Yeah, I didn't. Nothing's cheated. We're all good to go now. All right, so one thing I need to do is buy a new light. This light's been around since 2020. So it's a 6-year-old light, and it's having some, it's getting slow. It's getting slow, you guys. Second. All right, move it down. Adjusting. It says flickering. It's flickering. Okay. So where are we at now? All right. Let's do multi-blocks. All right. Almost there. We did this one. The hardest one right there. That's a hard one. Okay. Where is our forward? Here we go. Oh, maybe this should be fine if I remove that. Maybe. Oh, please work, please. Hey, okay, good. All right, excellent. Okay, where is our multi-headed part? We did that. I want the multi-blocks. We're gonna do more than one block now. Not just one. I want 3. I want to do 3 blocks. Is this done down here? Where's our blocks at? Here. Blocks. Here we go. Right here. Hey, there we go. Look at that. We fixed it. It only took us a good 30 minutes to figure that one out. I'm thinking that light has mental breakdown. It's flickering. I need to buy a new one is what I got to do. Because it's been active for 6 years. It's been a very busy light, so we need to buy a new one. Pass attention by reference. Yep. Squirrel Sniper. Yep, we did it. We did that. There you go. We got our pass by reference, and we got our output projection on the block. So let me see here. Add positions. We done? That counts. We did that. All right. To do. Let's look at our remaining to dos. We're not going to deal with that right now. Review. That's fine. Multi-attention, we did it. We did all the to-dos. We did them all. Let's look through everything that we've done so far. All right. Let's look through all of it. Real quick. Looks good here. Okay, look at how crazy this function is. Right here, look at this. Isn't that insane? That took us multiple days to figure that out. Lights waste energy. We should live in the dark. Oh, yeah. Well, you know what? In this case, I'm using LEDs. So I got LEDs all over the place. So they're very light efficient. Also, it's 100% powered by the sun. It is 100% solar. And did you know this entire stream? The computer, the monitor, the camera, the lights, my phone charger, this microphone, 100% solar. Yep, renewable energy, 100% solar. Thank you for the party poppers, you guys. Appreciate it. We did it. I'm pretty sure. I just want to double check that we didn't miss anything. I always, you never know. Good job, J-Bro. Thank you, J-Bro. Thank you. That's awesome. Thank you, Kyle. Appreciate it. You should make a Vim add-on or something so we can see the code live. Ooh. Well, I mean, technically you are, right? You're seeing the code live right now. We could, though. We could do something like bacon. You know bacon down here? This down here at the bottom of the screen? This is bacon. Thank you to Foodude on Twitch for setting us up with bacon. How you tackle procrastination as a coder? I stream. I'm doing it right now. I'm talking to you guys and I'm coding because you keep me... I have to, keep focused. If I don't, then, you guys will run away or something, right? You guys will leave me. What do you work on after this? Redless Saber, we've got a plan. Are you ready? So we're going to go to our ideas. I really... stream ideas. Here we go. So we've got RAG. We'll do a RAG next. I think that's going to be... that. You guys have been asking for a RAG for a long time. So I want to do TurboVec and Rust Axum. I think that would be really fun. I think we'll do that. And then I also want to build a generative imaging. I want to do generative, vision. What do you call that? Computer output make pretty picture. That's what I wanted. Computer output make pretty picture. That's what I want to do next. We've done that once on stream, and it was with my own algorithm. I want to do maybe something more state of the art. So I want to do that next. Computer make pretty picture. What is that called? Generative images? Is that what that is? If he doesn't code, we freak out. He's right. Exactly. I have to keep everything busy and flashy on the screen. It's got to be pretty. Otherwise you guys are like, what's going on? Could you work on React or React Native? Yes. I've been wanting to learn that. React is pretty great. I think React is pretty straightforward. I like it. The only problem is that it's very slow. It's very slow. It causes major slowdown. You can build it efficiently. I've seen it before. For example, tasksplit.ai. This is a React app. See how instantaneous that was? This is pure genius engineering right here. Pure genius engineering in order to do that. Look, watch, we'll reload. Boom, done. Right? Watch it again. Here we go. Boom, done. Third time. Reloaded. Instant. It's instant. Let's see. I know many programming languages, but I don't know how to build something. But yours really good to see. Yeah. Oh, thank you. If I want to code like you, can you give me some suggestions? Yes. You want to build simple projects. Start off simpler, right? Simple, build something good. Build something more complicated. If you want to go pure hard mode, tactician, or insane, build something that is really difficult that you have no idea how to build. And then you will have the most struggle and the most knowledge gained by doing that. For example, me, I took Rust and AI and put them together, and they are very challenging, right? And not only regular AI, we're building a transformer, right? ChatGPT. Right? Difficult. Quick fix. Check your other message. I heard you double click the screen. You like the video. Oh, you should test it. Does double clicking the screen work, you guys? I don't know. What happens if you double click the screen, right? You know, like tap the screen. What happens if you do that? Does it work? Matrix mode, transpose one contiguous reshape. Check. Yes. Okay. Contiguous. Right here. Here, I'll make it easier to read. So this is how I got it to work, Squirrel Sniper. Right here. That part. Right there. I think it's pretty good. You already moved the head dimensions to index 1. Transposing it again right before the matrix multiplication throws the internal inner dimension completely out, does it? Am I not doing this right? I thought I'm doing this correctly. So I transpose it here, I transpose again, and then I transpose it a third time to get it back to where it needs to go. Right? And then it goes, I've confirmed that it goes back to the right shape. I mean, I guess it has to. Does it matter though? Because of the shape that's in? Actually, I don't know. We're gonna try it. Hey, Squirrel Sniper, we're gonna see if it works. So that'll be something that we probably will be doing tomorrow, is the beginning of the training. We're gonna be, because I think we're done. Did we do all of it, you guys? Is this it? Did we succeed? Did we do our final output projection on our... So this is the block. We did our forward. We did our tension on the block. We did multiple blocks up here. Right here. Right there. And then we didn't do our final output projection yet. All right, so we have to do one more output projection. To do final output projection. I think we have it defined too, right here. So I think we could just say let out equal self dot final projection dot forward output return out done. See, oh, we got to do ampersand. Thank you for the hearts, you guys, appreciate it. Right there. See if it runs. Boom. Success. That looks pretty good to me. Hey, now all we have to do is train it. We have to build a training loop, though, before we do that. So there's a bit more work that we have to do. Remove the inner transpose. Are you sure? Are you sure? Do you know for sure? All right. Because I finally got it to work. It only took me an hour. All right, so here, let me see what you're saying. Fix, remove the inner transpose on value. Where's our value here? All right, so value, where is it at? Value here. Oh, you don't want this one. Oh, wait, oh, you don't want this, is what you're saying, Squirrel Sniper? Bro looks, hey, Rose Thorn, good to see you. Welcome on in. Happy Sunday. Good to have you here. Welcome on in. We are building ChatGPT in Rust. That's what we're doing right now. Rust is a programming language that is very difficult to use, and it is very powerful. Very powerful. Thank you, Kyle, for the moderation. All right, you guys, let me see here. I want... so you're saying get rid of this, right? So this line right here is what you're saying? The transpose, you don't want that? Remove the inner transpose on value. So then you can do batch, sequence, heads dimensions. Oh wait, I also don't need to do this. I could just say features. Like that. Which is this, oh, that was your code. Got it, that was your code. Yeah. This is identical, these two things are identical. Right there, they're the same. Ban that guy right there, Stevie. Yeah, Squirrel Sniper. Yeah, all right. So, all right. We'll try it out. We'll try it out. All right, so no transpose. Here we go. I guess that worked too. Okay, Squirrel Sniper, thank you. Squirrel Sniper. Here we go. We have to say this. At squirrel, IRRL, sniper, 138. Thank you. And then we throw a heart symbol. There we go. Squirrel Sniper, thank you. We removed the inner transpose. Exclude inner transpose for value. There we go. Right there. All right. Looks good to me. What happens if we got rid of contiguous? I'm still not familiar with that. It doesn't seem to need contiguous either, because we're not transposing it anymore. If we were transposing it, we would need to contiguous it, because that would be a problem otherwise, I think. So I think we just do reshape. Does that make sense, Squirrel Sniper? Do we need contiguous still? Do you guys know? All right, Google contig. Gotcha. Is it? You think so? Is it? Google continuous TCH Rust contiguous. What is that? I gotta put this in quotes here. There we go. Okay. Contiguous. Let's see. What does it do? What does that do real quick? I forgot. I know it's something to do with memory, because when memory in Torch is all one giant list of numbers, it's a vector. Basically, it's a one-dimensional vector. And you create metadata views over the top of it. When you do contiguous, I think it forces a copy or something. I mean, when you create a tensor view, transpose or slicing, the tensor shape strides change, but the actual data in the memory remains scattered or non-contiguous. Calling contiguous forces PyTorch to allocate a new memory block, see, and rearrange the data. I told you it's a copy. It was a copy, not just reshaping. Sounds good. Squirrel Sniper, we're learning together, aren't we? Hey, you guys, if you didn't learn anything you knew before, you do not need to use contiguous if you are just reshaping. If you're transposing and reshaping, you're going to need to use contiguous so that you can reallocate the block, because you can't double mutate the metadata. It would cause a problem otherwise. It would be an error. Mandatory and specific operations because of how memory layout works behind the scenes in libtorch. Yeah, Squirrel Sniper. Hey, Squirrel Sniper, thank you. I don't know if you saw my message about React or Flutter because my internet cut off. Oh, I did, Redless Saber. You know what? I think did we add it? I don't think we added it. Did we? All right, let's do it. All right, so build React TS. All right, so we will build a React app. Build a React app, and that would be JavaScript. Do we have JavaScript in here? We don't. We should. That will be JavaScript. I'm gonna say other, and then we'll say post. All right. Boom. Build React TypeScript right there. Space creating a non-contiguous tensor layout. Yeah, Squirrel Sniper. Rust does not actually recognize the numbers inside the computer's physical memory chips. Instead, it barely changes the metadata. Yeah, exactly, the metadata. Hey, Kyle, guess what? You were on the right track there. You were. It was that all along. It was. And it was what we had to work on to get it fixed. It was, Kyle, it was. Yep. Just a little bit of adjustments. Just a teeny smidgen of adjustments to make it all work. Oh my God. I know you were right. You were. Kyle, you were right. All right. So where do we want to go from here, you guys? I would like to make sure that we're getting all the data forward through in the model. So let me make sure that everything looks correct. Let's see here. All right. So that's all Squirrel Sniper stuff. We did layer norms. More Squirrel Sniper things here. Thank you, Squirrel Sniper. Look at Squirrel Snipers all over the place. All right, and then I want to make sure that everything looks good. Let's just walk through the code really quick, you guys. Let's just walk through it. Okay. So we've got our path or route for the var store, device token. We got our tokenizer, head dimensions, which I specified as 1, maybe. I think. So where are we getting our let's see, I think we're doing this in main, right? Let's open up main really quick. Let's see here, transformer. And I want this to be 4. Save that really quick and make sure that still runs. Oh, nope. Let's see here. Run, thank you. All right, looks good to me. Make sure we print our output to make sure that it looks pretty. Looks pretty to me. All right. Back to some network issue. Oh no! Had some network issue. Quick fix. Oh, you're back now. Right, okay. Good to have you back. We're almost done with our entire model. All we gotta do is create the training loop and the batches. So that might be something we do tomorrow. We might do that tomorrow, you guys. Today, we're not done yet. Hey, Donut Dude, good to see you. Welcome on in. Happy Sunday. Today, create an anime with your voice. Also, create international website. No way, Vanish. That sounds really fun. You should share it in Discord. Share the link in Discord. Rose Torn, your last message won't be allowed. Yeah. Got some mods, you guys. Hey, thank you, mods. Appreciate you. We shall see. It's gonna happen. Get some of the side performance you found with multiple calls of PubNub on somehow, and it was slowing everything down. Ooh, you fixed it though. Nice. Good to hear, Kyle. All right, let me double check you guys really quick. All right, looking good. Yep, I like it. 15128, that's correct. Now, let me double check. Okay, so here's what we got to do tomorrow. Yep, they're right here. Optimize that right there. To do, we need to write the training loop. That's what we got here. The turning loop. Training loop. All right, we got to do that. We got to write the training loop. Do we define an optimizer? We got to get an optimizer in there. To do, define optimizer. Probably like Atom W, probably, maybe. I don't know, right? Maybe. What? And then our criterion, which is negative log likelihood loss, maybe, or is it cross entropy loss with logits? Yeah, that's it. That's it right there. That's the one we want. We want the criterion to be this. Cross entropy with loss and the logits. Okay. So this will be the plan for tomorrow. He had something about you, Steven. Wait, yeah, he did, right? I saw it. I did. Okay. So that'll be the plan for tomorrow. And we need to do batching as well. Okay, so that's it. All right, so we need to do batching. And I'd like to do batch shuffle. Do a little batch shuffling there. Can you give me some tips on the AI workflow setup to build apps? Like you said, set up 10 agents in one go. I don't know if you need to do that, Rox. I don't know if you have to do it like that. That might be a little bit too much. That might be a smidgen too much, right? You don't need to... It really depends on what you're trying to achieve. So let's read your message really quick one more time, and then we'll get back to our to-do list here. Hey, can you give me some tips on the AI workflow setup to build web apps? Like you said, set up 10 agents. My recommendation is just to use anti-gravity, Codex, or Claude. Is that what you're saying? I think that's what you're saying. I'm pretty sure. You're just like, which AI to use? You don't need to do multi-agent because it's too simple of a task. It's too simple. Okay. Let's wrap up, you guys. Claude in the terminal. API paid. There you go. That's the way to do it. Right this. Like Claude right there. Like that, you guys. Right there. A little bit of Claude. That's all you need. Right there. Okay. So, where are we at here? Transformer output. So this is one feed forward. So this needs to be start the optimization loop here. All right, I'm going to put a to-do in here. So this is our plan for tomorrow. I'm going to put this here. There we go. Looks good to me. Okay. Now, let me double check. Let's reread everything in the transformer here. Let's read through it, you guys. Okay. We've got our tokenizer embedding positional encodings. We've got blocks. We don't need this anymore. So see, already something we found. We don't need this anymore. So let's get rid of that. Yep, there we go. All right. Go back to the top. Because we're only using blocks. Let's make sure we didn't break anything. Okay, get status. And then we're gonna say we added multi-headed attention. Party popper. Do you guys put emojis in your git commits? I do. I put them right there. Pay as you go. That's the way to do it. Different from the chat bot. Yeah, there we go. Thanks for the hearts and party poppers, you guys. Minecraft music makes me cry sometimes. Not gonna lie. It's pretty good. No? All right. All right, you guys, this is great. So, positional encodings of blocks. Output projection. Yes, we used it. Double checking. Yep, right there. Looks good. our device, our heads, which we set properly. Let me double confirm here. Run. Make sure that looks fine to me. Okay. Heads. Double check that we are using this correctly. Yeah. Yep. Tensor. Heads. I-64, the transformer block. Oh, whoopsie doodles. All right, that could have been a problem right there. Good thing we made the same number. I would have been confusing. Steven, want to peek into my next project? Absolutely. Squirrel Sniper, absolutely. Anti-gravity setup is free. Yeah, got good anti-gravity, you guys. Zero network synchronization, 2 device placed within the same room can securely verify proximity and cross-reference data state instantly. You mean instantly? Are you talking about quantum entanglement? Without ever transmitting a single byte of data. Quantum entanglement! That sounds like quantum entanglement to me. Nostalgic, see stuff built with my kids and remember the times. Oh, yeah, that was a lot of fun. I like remembering to the good old times. The ones that get me are sometimes seeing like the Disney movie VHSs, things like that. Like, oh wait, I remember that. I remember those days. Okay. So let's see, make sure we got all our heads correct. Yeah, no more craziness going on there. Okay. Is this correct? Okay. Yeah. Dropout. All right. So we did a little bit of dropout. We didn't do enough, but I think we did a little bit. We did a little bit of dropout. Let's do more dropout. I think I'm missing a little bit here. So, let's see, projections, attention projection, dropout, self.dropout, and then don't we need to say training or not training? Yes, self.training, self.training. All right, how about that? All right. We're just doing cleanup, you guys. We're doing cleanup now. Okay. Dropout vocab. Yep. Blocks. We got 4 blocks. I suppose we could say number of blocks. We could do that here. How about we do that? Let's put it here. Number of blocks. Colon I-64. Go to main, and we say transformer, and that is going to be right after tokenizer, and we will say 4x4. 4 blocks with 4 heads of 128. Rebuild it. Looks good. Okay. We didn't break anything. All right. Tokenizer blocks, output projection, device, heads, dimensions, dropout, training. Okay. All right. It's nostalgic. I see stuff. Oh, wait. I already read that. Sorry about that. 4x8, 2x8. Snot. Hey, snot. Yep. We got those. We got a lot. We got a lot of. I'm with you on that. We are doing a 4x4 by 128 is what we're doing. Physical environment purely on the unique electromagnetic fingerprint. Oh, wait. So, wait. App establishes an immutable record of a physical event. So, are you doing specific room temperature? Oh, no way. Squirrel Sniper. That sounds pretty interesting. Okay. Sounds like you're building a house. Oh, it does. Right. Yeah. 2x4. 4x8. I see what you're saying there. Those are sizes of wood planks, you guys. Wood planks. In our side, we're talking about matrices. All right, for tokens, embedding. Did we get our positions? Yes. Positions. And then we do our blocks. And then we get our output projection. Looks good to me. Get rid of that. Okay. Clean it up a little bit. Positional encoding. That one's fine. That one's easy. We do have a max token size, but it's configurable, so we don't need to worry about that right now. Transformer block. Dropout, training, projections, norms. Oh, wait. We don't... do we still do 3 norms? We do. Okay, we still do 3 norms. Only 2 linear layers, though. Okay. Device heads, dropout, training, queries, projections, norms, and linear layers. We've got our forward output, query key value projections. We run it through the attention, and then we norm it. And then we do a feed forward. Yep, it's all there. I'm seeing it. Looks good to me. Let's run through attention now. We have our attention. We grab our dimensions, which is going to be batch sequence features. Features is 128. Sequence will be 5, and we're doing a batch of 1 for our test. Heads is the number of times that we split our dimensions, our features. So we split our features, and then we reshape and transpose. Then we scale with our square root of the number of heads. We apply a causal mask, then a soft max, a dropout, and then a final output with our attention on the value. So it's basically the very tail end of this here, right here, this part. This is the final output right here. So of the attention. Then we do a final output projection, which we need, or maybe doesn't matter. It's fine. Okay, that's it. That's the transformer. We did it. Right there. We're ready to start training the model. Now, hopefully, because we spent a long time putting this all together, right? About a week. It works. That's right. Hopefully it works. We just need to create our batcher, which is going to split all of our data into training shapes that allow the model to learn. So we have to do some data manipulation, a little bit of data manipulation. Once we do that, we can throw in it to our optimization loop, which is the training process. Boom, we did it. We rebuilt GPT. That's it right there. So that'll be the plan for tomorrow, you guys. Thank you guys for the party poppers. Had so much fun with you today. We did it. Here, wait, let me commit the code real quick. Git status, git add. We did some cleanup. Git commit am. Cleanup of old unused code. Push the main. Boom, done, easy. My airlock protocol holds every token under security. Ooh, a secure tokenizer. Have you heard of the markdown files after every session? How to handle memory for a long term. Rocks. All right, so here, check this out. This will be like my last story for the day. It's very important, very critical. These large language models, they do not like you to put too much context into the system. If you use markdown files for memory, you might be making a mistake because the quality of the output of the model falls off a cliff. It gets things wrong or it does things weird if you use too much context. So the ultimate goal is to have minimum context. Do not use markdown files if possible. If you do use markdown files and you need it to help the model understand something very special, make sure it's 1, 2, or 3 lines in your markdown file. And there's no more than that. Do not use memory. You don't want it to remember things. You want it to be able to achieve a specific task. They have been all optimized on goal-achieving tasks. So when you paste text like your prompt into the AI to do work for you, make sure you give it a goal so it knows what its target is, and you give it minimum possible information to be successful. And make sure it's minimum. Otherwise, you're going to spend more money burning tokens, it's going to go slower, and you're going to get a lower quality output. So those are the tips for you today on the LLMs to generate code for you. Thank you for the hearts, you guys. All right. Avoid layers of abstraction. Learn subtractive engineering principles. Subtractive engineering principles. That's a real thing. You want to minimize. That's the whole goal. Yep, Kyle, you got it. AI can read code. If you're specific and each file is a system, you can work inside each component. Yes, exactly. Exactly. All right, guys, I'm headed out now. Thank you so much for joining today. We'll be back tomorrow. We're going to be building more. We're going to be training the model. We have to do our batching, and we have to do the optimization. Specific, minimal. Yep, there you go. All right, thanks. You're welcome, Rocks. All right, you guys, thank you so much for joining. Back tomorrow. See ya. Have a good rest of your day. Oh, Food. Is there some concept of context compression? Markdown sounds pretty bloated to me. It is, yes, it is. Compression, Markdowns is pretty good. If you want, basically, you can just do regular text. It doesn't need to be Markdown format. Just regular text. if you want and minimize it, like caveman speak, really. It's caveman speak. Bye, everybody. See you tomorrow. Thank you for joining. Bye, everybody.